Hello, world, and welcome to another episode of
Did You Know?
We love to talk about exciting subjects in science, medicine, robotics, astronomy, futuristic ideas, music, or anything interesting in the news. So let's get into it. Did you know in the news? Earth's inner core may have started spinning the other way. Scientists have found evidence that Earth's inner core, a hot iron ball the size of Pluto located around 5,000 kilometers below the surface, has stopped spinning in the same direction as the rest of the planet and might even be rotating the other way, according to the research published in the journal Nature Geoscience. The study authors Xiaodong Song and Yi Yang of China's Perkins University found that the inner core rotations came near a halt around 2009 and then turned in an opposite direction, and that it changed directions roughly every 35 years. However, experts have expressed caution about the findings, pointing to the other theories and warning that many mysteries remain about the center of the Earth. Let's move on to our next story. China says it may have solved a mystery on the moon's surface. Scientists have reportedly solved a long-standing puzzle about the origins of a mysterious element on the moon, with the help of lunar samples that were returned to Earth by a Chinese mission in 2020. The Chang'e 5 mission scooped up about 1,700 grams of lunar dirt from an unexplored region that was volcanically active within the past 2 billion years. The study found that the ferric iron Fe3+, a version of iron that contains oxygen, which was previously assumed to be rare on the moon because the lunar surface is chemically reductive, meaning that it is not easy for oxidation or oxidized compounds to form, can be forged by teeny rocks called micrometeorites that constantly pelt the lunar terrain. The discovery reveals a dominant pathway for the formation of Fe3+ on the lunar surface and suggests that much more ferric iron could be present on the moon than previously thought, and that its abundance is progressively increasing with micrometeoroid impacts. Our next story is rare antimatter from distant space reaches Earth and can help find dark matter. Scientists have discovered that components of antimatter, which is a bizarro version of the regular matter we experience in our daily lives, can travel thousands of light years across the Milky Way, according to a new study. The discovery can potentially shed light on the nature of dark matter, an unidentified substance that remains one of the biggest unsolved mysteries of the universe. The scientists used the ALICE detector at the Large Hadron Collider to estimate the transparency of our galaxy to helium antinuclide, a measurement that makes it impossible to estimate how far these particles can travel before they encounter regular matter and disappear. The results revealed that antinuclide may indeed voyage across the Milky Way to reach Earth, making them a very promising channel for the discovery of dark matter. Our next story is Milky Way found to be too big for its cosmological wall. An international team of scientists have discovered that the Milky Way is too big for its cosmological wall, and that it's more unique than previously thought. Cosmological walls are a flattened arrangement of galaxies that surround other galaxies, characterized by a particular empty region called voids on either side of it. The new study, which based on the state-of-the-art computer simulation part of the illustrious TNG project, shows that the Milky Way is too big for its cosmological wall, something that has yet to be seen in other galaxies. The team suggests that it may be necessary to take into account the special environment around the Milky Way when running simulations to avoid a so-called Copernican bias in making scientific interference from other galaxies around us. Our next story Rubble asteroids nearly impossible to destroy. Researchers from the Curtin University have found that Rubble asteroids are nearly impossible to destroy. According to a study published in the Proceedings of the National Academy of Sciences, the team studied dust particles collected from surface of asteroids. Itakowa, if I said that incorrectly, I apologize, which is 2 million kilometers from Earth and around the size of Sydney Harbor Bridge. They found the asteroid was composed of rocky rubble and dust, and is hard to destroy with resistant to collisions. The team also found that Itakowa, if I said that incorrectly again, I apologize, is almost as old as the solar system itself, and that its survived time is attributed to the shock absorbent nature of Rubble material. The study suggested that the Rubble material asteroids, which are made up of loose boulders and rocks, are nearly impossible to destroy and have a long survival time in the asteroid belt, making them a significant risk if one of them were even to hurtle toward Earth. The findings from the study of the asteroids Itakowa, which is 2 million kilometers from Earth, could aid in the development of defense strategies against asteroid impacts. The researchers used 2 different techniques: electron backscatter diffraction and argon-argon dating to analyze 3 dust particles collected from the surface of the asteroid. The study found that the Rubble asteroids are resistant to collision and shock, and that they are more likely abundant in the asteroid belt than previously thought. The research has been published in the Proceedings of the National Academy of Science. As you can see, there's a lot of things going on around us. Let me know your opinion. Any thoughts? Until next time, stay safe, and I'll talk to you soon.